Cool. Yeah, we'll just get started. This is pretty chill. So yeah, hi everyone. My name is Teo. I'm from Ross. We flew in from San Francisco just a few days ago. Uh, we also have a few members of our team here. So we have Gopal over there, who you might have seen earlier. We also have Ananya, who's on our platforms team, and I'm on the AI agents team. And we build agentic systems at enterprise scale. Or yeah, so that's what we do. I think a little bit more context about what we actually are, I think is helpful because I don't know how many of y'all are familiar with sales systems because I am not coming from a sales background at all. I studied computer science at Stanford. I was like, sales, what is this whole thing? Until after I joined this company. Uh, so I think a little bit on that. Uh, so what Rox does is it does five things mainly. So we do research, discovery, engagement, monitoring, as well as planning for all stages within a sales pipeline. So that, if you're a salesperson, you might first try to, do some research on who to actually reach out to. Maybe that's your potential customer, a potential client, a company, whatever it may be. And then, once you have that research initially done and figured out, you might actually want to try, reaching out to them. And traditionally, this has been a very manual process of doing all the research work, right? You would go on Google, go to LinkedIn, try to find individuals, or use your network, right? A lot of networking efforts are needed to do such things because it's a very social uh, activity, I guess, to put it in one way. But uh, you know, there's only so much, time that a human can spend on scrolling just about a single person or a client or a company versus if we have AI agents that can, scrape the web for you or, dive deep into a certain topic, uh, theoretically, you could save a lot of time on all that boring base work that you need to do and just get right into the actual meat of the job, which is, doing the sales part, reaching out to people, talking to other humans, which is, something that AI cannot replace at this point in time, at least. So yeah, that is Rocks. Anyone have any questions about Rocks at this point, or we can move on? It's pretty interactive. We can keep this on. Sure, yeah. Yeah, you can have a seat. It's fine. A quick recap about Ross, at least, is we are an AI sales platform. So we help people become better salespeople by supercharging them with AI tools so that they can do better research, discovery, engagement, monitoring, planning, so on and so forth. Today, we wanted to talk about building AI agents in general. Oh, yeah, go ahead. Rox was founded 2024, so last year on Valentine's Day, which is February the 14th, I believe. That's how I remember it. Yeah, so yeah. So we are about a year and a half old at this point. A lot of growth. A lot of growth in those throughout those period. So it's very fun, very exciting. But yeah, today we are just gonna talk about our how we use AI, how we build out AI platforms that scale at enterprise level, because we have a bunch of data sources that we connect to, like Salesforce, Snowflake, whatnot. We also have a bunch of unclean, raw data that we get from external data sources. And we also need to, build an AI platform that is, manageable and also scalable at our speed of growth, which is pretty immense right now. Because a lot of the things that we build are, you know, it's pretty early on, I would say, right? Like even if you get this most senior staff engineer that's been working in the industry, all the at least the LLM stuff that's been going on is pretty new in terms of the timeline of computer science if you take that as a whole. So we're trying to build reliable frameworks and designs that can last us for a long time while being able to treat these non-deterministic LLMs so that it's at least controllable to a certain extent so that we can get verifiable, reliable results. So I guess what we can do is we can start out with a few problems that we experience uh, internally. And I'm sure, a lot of companies are also dealing with that. I think Claude Anthropic was speaking of. right ago, and they were also talking about like agents versus workflows. So it's a pretty common problem across the industry. But one main thing is context management. So I guess to step back, context refers to everything that's within the LLM or the agent's, you know, thinking space is how we put it. But any tokens that are in to the as given as inputs to the LLM are basically context, right? So whether it's handling memories, whether it's long-term memory or short-term memory or ephemeral memory, and we'll define those terms. So long-term memory is going to be anything where that's sticky throughout the user's context. So ChatGPT, Claude, they all have memory management stuff, right? If you say, oh hey, I like uh, TV shows, it will remember that next time you ask, like, hey, what are some favorites that I have to look at? It knows, oh, you're talking about TV shows. Uh, Short-term memory, I think of it more in terms of a whole conversation. So each time you create a new conversation, that starts out a new clean slate for your LLM. But within that conversation, you might be specifically talking about best restaurants in Cambridge, Massachusetts, or something like that. And we want that to persist throughout the session. We also have things like ephemeral memory, which is very short-term things. Like, for example, what are you looking right now on your screen as you talk about something? So, for example, you might have an email pulled up, and there might be a chat window on the sidebar. You know, at that point in time, that email is extremely relevant to that conversation, right? So that has to be part of the context, but also figuring out as soon as the user navigates away from it, we need, some reliable way to get rid of that from the context, or so that the LLM isn't, biased towards, that source that was used earlier in the timeline. So things like that, context management. Uh, we also have things like, very traditional software as a service issues, like having business logic, because, right now a lot of our agent implementations have tools, and tools are just magical functions, right? The LLM takes in a function schema as an input, and it can call other functions. But, as soon as you put in, business logic in there that, tries to access database or, whatever it may be throughout your code, you want to make sure that everything stays consistent, right? So handling all those consistencies within your agent, as well as the actual software that you actually have, which is like the traditional SaaS type software. Uh, and there's also, resource issues. So for example, you might have multiple agents running, and a lot of times with agents, assuming that you're using a third-party API provider. So if you're abstracting away the inference part to OpenAI or Google or Claude or Anthropic, whoever it may be, it's about, how can you parallelize those requests? Or, even things like when you're running tools, can you parallelize different tools? Uh, so, there's a lot of axes that we can work on to, tackle performance issues, or whether that's in terms of speed, time, or also the reliability of the content, like the quality issues. Because if the quality of the output is bad, then no one's going to trust your output, and you might as well, not have run that query because it's just, give you garbage. I guess commonly hallucination is like one of the big factors that count in towards that. So yeah, so those are some things that, kind of set the background, that set the stage for what we're going to talk about. Does that make sense? Any questions or comments, disagreements, any interjections? No? Okay. Yeah. Feel free to, just like interrupt me at any point in time. Let's try to keep it interactive to a certain extent, but I know it's pretty hard. So yeah, that is what we have. So let's see. So one thing that we built internally, so one thing that we noticed, I guess, was that a lot of our users are not prompt engineers, right? I'm sure everyone has heard the term prompt engineers before, engineering before. If you have not, that's the engineering, quote unquote, of figuring out how to leverage these LLMs the best by providing the best input to, sentence or, paragraph to your LLM so that, you can, make the LLM do whatever you want to do. And a lot of our users, I'm sure a lot of you are very proficient at prompt engineering, whether you use it for school assignments or work or whatever it may be. But a lot, and also, coming from an engineering background, it kind of makes sense. Like naturally, it's your tendency to, tune the prompt so that it gives you the best output. Or, if something doesn't work, you're going to try something else. Maybe you're like, oh, hey, let's try feeding in, an example. And you're like, oh, voila, it works. Uh, but a lot of our users are not like that, right? They are very used to, just thinking of these chat agents as, just a friend that you're texting. They'll be like, hey, what's going on with, my account, for example, with us, right? And your LLM is just gonna be like, what's going on, or what's up with, your, some company, what's up with my Stripe deal? Doesn't really make sense, right? Like, what is what's up actually asking? Because if you ask, another salesperson, you're like, that it's about, oh, are all your communications going well? Is the research going well? Is the deal progressing? Things like that. But your LLM has no clue on that, right? Uh, so our main issue that we had to tackle was translating, is how I put it. Translating the very human input into some prompt that can actually start up our agent framework so that it can actually do something useful with it. So a lot of techniques I've seen, but what we have decided upon for now is orchestration. So given a prompt, we have a whole layer of orchestration so that we can actually turn that user input into actionable items. So how we do it is we have a bunch of example workflows that our users most commonly use. So, in the case of sales scenarios, whether it's like writing up an email or checking the status on what's going on with your uh deal, or what other examples could there be? Maybe summarizing a transcript, or there's endless scenarios.
Reaching out, like sending an email campaign to a bunch of potential customers, stuff like that. Like,
Yeah.
a lot of stuff that people implicitly want to do, which are like embedded in like the sales workflows. That makes sense.
Yeah. So a lot of those cases can, we know how to do it the best, right? Because we also have our internal salespeople using our only using Rocks to run our, we only use Rocks obviously to run our sales team. So, iterating with them, we know like what kind of stuff salespeople want and need. So we can pre-orchestrate a lot of these workflows by breaking down problems into smaller actionable steps that agents can work on. Yeah.
So I'm a customer,
Mhm.
I'm in sales, and I want to start using Rocks to help me with that. So
Mhm.
what exactly, like, how exactly am I using Rocks, or how exactly am I being helped? Like, I just don't get the.
That's a good question. Yeah, that's a very, what's your name, please?
Wasim.
Wasim?
Yeah.
Yeah. So Wasim asked, like, what's the whole point, I guess, is like, or like the purpose? Like, how do I actually use it if I was a salesperson? Yeah. So I would say that it's the best use case is that it saves you time, right? Everything we do is for efficiency, right? It's not going to replace a salesperson, right? Because inherently the sales process consists of a lot of like human interactions, right? You have to go meet someone to sell something, right? We can't just send like an AI agent that calls you, or whatever it may be. But what we do is, for example, before you meet someone, you have to do a lot of research. Like you need to figure out who their manager is, who their boss is, because the boss is going to make the decision on whether you're going to buy the product or not, or like what kind of industry are they in, what kind of news happened. So maybe there's a certain event. Like for example, let's say I'm selling something to MIT, and there's like a new events that happened in Cambridge, right? There's a new construction happening. And if I was a construction company, I would see like, oh, MIT was looking to build a new building. Maybe I should reach out to MIT, right? But a lot of these research, they're very time intensive because you just have to go to Google and just like start scrolling on, a bunch of news. Yeah, brute force things. But we can have our agents do things like that. Or, for example, reaching out and sending emails. Uh, it's like a number game, right? If you send out 10,000 emails and you get a 10% hit rate, you're gonna you're getting something, right? So say that you want to schedule like a bunch of automatic emails to potential clients. So all of this is about exactly.
And the great thing about Rocks there is that like we have all the context on like how you run your sales process and the data in your thing. Obviously, like a generic auto email send products have existed for like decades. But like the critical thing we bring is actual like real context on like how you run your process. Long-term. Exactly.
Yeah.
So that's how we shine.
Yeah. And it's also like connecting to your private data sources, right? Which is what differs us from, a generic chat product like ChatGPT or Gemini or Claude, because we know, like when you ask us like, how are things going? We can actually translate that into something useful. Versus if you ask ChatGPT, it's going to be like, oh, my day's going well. And, be saying a bad thing or like whatever it does these days. Yeah. So yeah, it's adding that sales specialty and supercharging, which is why we brand it as, we make the best salesperson even better because, they can now do so much more things and actually focus on the human aspect of that sales prospecting, etc. But yeah, that's a very good question. I mean, I also did not come from a sales background, so yeah, I also have that question. Yeah.
I think we got the point, like, you're building, so you have the context of a company that
Mhm.
are leading sales, but how exactly, what's the tech, like, are you doing RAG, are you doing context management, are you doing fine tuning or some setting?
Yeah.
What
Yeah.
Yeah. We'll get into that, but yeah, this was
Are you talking about the graph as well and all that?
sure. Yeah. Yeah. We're just trying to set the stage because it is a very good question, but trying to figure out why we do that. Uh so yeah. So we'll start with orchestration, right? So how do we actually translate user inquiries into something that's useful? We have a few heuristics that we can actually use. So, for example, how relevant is a or for example, say that the user asks, write me an email to MIT and I don't know, some Starbucks, as your potential clients. Uh, those two are very distinct because they have a very different context. If you draw a circle, like the set of those two circles, I don't think they overlap much, right? Very two different business. So we don't want one email thread that's supposed to go to MIT to overlap with Starbucks or whatever it may be, right? So our agent needs to be able to figure out like how do different context windows overlap versus not so that it can keep things clean and separated. So that's like one way we can tackle those problems. Another way is how big or a task is. And when I say big, it could be in terms of time as well as how complex it is. So if it's hitting a lot of different data sources at once, the context window is going to be very messy with all sorts of different data flying around. In that case, we might want smaller texts so that, hey, let's go fetch your emails first and then do a little summary on those emails before we take a look at your, Google Drive files. Or if something's going to take a really long time, maybe it's better to break up those tasks into smaller pieces so that we can keep it manageable. Because the whole point of orchestration was that, oh, we want reliable results from an LLM that, is not always reliable or is deterministic at all and is very prone to, getting distracted within your in context, learnings, right? So keeping those things isolated. So whether it's time or, the number of data sources that's being hit on, the complexity of the task, we can abstract it away as that. And also, another thing is how people think, right? Because LLMs are trained on, human language, it's, to a certain extent, it's pretty similar to how we think as we do a task. And, for example, if I were to, do some research, I would, whether we go breadth first or depth first, things like that. So, theoretically, you could if you have a task, you should be able to draw like a direct acyclic graph of all the steps to complete that task, right? So for example, are there dependencies within each task? So say that, you are trying to summarize what MIT is as a school, for example, and I'm trying to sell to MIT. That's a very big task, right? And if you just ask, an LLM to do that, it's either just going to give you some random result like, oh, hey, MIT was founded in this year, blah, blah, blah. And, but if we want something actionable, we can break that down into several steps. So for example, hey, go take a look at the relevant news, take a look at any of my contacts, see if any of them are from MIT. But looking at the relevant news and looking at the contacts, they are not dependent upon each other, right? So we can run those tasks in parallel, theoretically, versus if we have things like, take a look at your contacts and write an email, those are dependent tasks, right? So we would require a very strong dependency on that. So trying to figure out like how tasks are actually mapped to real world functions, I guess, because that's what we have in terms of tools, right? is like a big step towards orchestrating those tasks, as well as the time, duration, and the effort that it takes. So that's the whole orchestration flow. And we also, and I'm sure you've seen other tools use to-do lists to keep track of their tasks. You might have seen Claude Code do that when it does a little, hey, I'm, doing this. Same thing. Similar in design where, we try to keep the agent on task by reminding it what the last thing it did was, what the next thing it should do, and how everything builds up so that, it has the big picture as well as the narrow vision of what a single agent is doing at that place in time. Does that make sense? Yeah. Uh, let's see. We can also now talk about how our data systems work. Do you want to give a brief about the graph?
Sure, yeah, I can do a brief, so before you feed into like agents or LLMs, one thing that we recognize is that there's a lot of different data sources that go into the sales process. So for example, Salesforce is where most of the data lives, but there's also like your Google Calendar, there's like your email, Gmail, Gmail, Outlook, there's a bunch of transcript recordings, so there's like hundreds of different like ways people report transcripts, et cetera. A list of contacts, which like live in LinkedIn, live in Salesforce, live in blah, blah, blah. And people often, big enterprises have like their own custom data warehouses where we don't even know how they're storing their data, right? Like ahead of time. So what we do is we build this thing called a knowledge graph, where it's essentially like it's a generalizable data layer where we can take any sort of data system, hook it up to this knowledge graph, and it will automatically ingest the data, do this thing called entity resolution, that's an extract of the relevant entities, and then since you have multiple data sources, you like build relationships between the entities and resolve entities that are the same. So for example, you have your Google Calendar, you have a bunch of meetings. Well, the meetings have email addresses on them, but we also have your list of contacts in Salesforce. We'll pull up those contacts and then we'll make sure that like there's an edge between like a contact and a meeting with that contact. So we're essentially like doing all this work ahead of time of like taking all this data, putting it into our knowledge graph and building all relationships in the data. The alternative here is to have an agent which just calls APIs, like calls Google Calendar API, calls this, but that's just not going to work, not going to scale. And because again, like every enterprise has a different way of storing it. So we do all this work ahead of time. And even I'll give an example, even for public data, like you can just search the web, but what we actually do is for each of the customers you're tracking, we actually do targeted web scrapes for those customers, which are like personalized to like what your company is trying to sell. And it will then turn those like news results into actual pieces of structured data where like it'll be tied to the companies and tied to like relevant contacts of the companies and so on and so forth. But this kind of work is actually very core to Rock, just like pre-agent orchestration work. And this is like this knowledge graph layer. And once we have this knowledge graph layer, we feed the data to the agents through this. I think this pre-work, because we have a good sense of like what goes into sales, we're not just solving like the general problem of like be my general assistant. We can actually do this, but we're also building in a general way where you can inject any data source. And then that's like the context I built in. So, yes, go ahead.
I guess my question is like, okay, I'm a company and like I'm using Rocks and like Rocks has all of this data about the Google calendars, my contact
Correct.
information, all of this.
100%.
Is this like manually inputted by me?
No, also what you have to like for security reasons, you have to go and click a button that says connect Google Calendar.
Okay.
Like obviously, like we're not like, and some companies
Connect your contacts.
exactly,
Okay.
and like I mean, it's not as simple as just connect with something like Salesforce, is like a heavy ass product. Like we have like a whole team, forward deployed team that helps our customers understand. Like our customers often don't even understand what's in their Salesforce. It helps them understand how their Salesforce data is structured, helps them connect it into Rock. So just like it's a non-trivial process.
Right.
But once you have that connection going, our knowledge graph just starts injecting all this data, cleaning it up. Yeah, go ahead. Does that make sense?
Yes.
Yeah. I was wondering, like, is it a big problem, or like, how do you guys handle, like, when these data sources are constantly updating, like?
Yeah, so I mean, so we have like this graphical process that runs in the background like every like 5 minutes.
I see.
And like it like tracks deltas and like does like there's it tracks deltas, it like does like on the fly entity resolution and like resolving these graphs. So this is actually a extremely hard technical problem
Yeah.
that we made a really bold decision at the start of the company to like we could have just started by just building some APIs and like building some agents, like just like start living. We chose intentionally at the start to like invest in this infrastructure because we know long term we're not going to win unless we have this infrastructure. So there's a lot of people, amazing people who work on this at Rock, and I think I would argue that even without the agents, we're still providing a ton of value by doing this. because there's lots of things you can do with this knowledge graph setup. But the number one use case is actually then feeding that shift agents to like actually like do it. Does that make sense?
Yeah, yeah.
Yeah.
Yes.
How will my company's data be protected? For instance,
Correct.
like my clients and flows where.
Good question. Generally, like speaking, like they have to sign a contract which allows us to store their data, which like. So first of all, for most companies, they just like, they're okay with us like storing their data. Cause they sign a contract with us in terms of feeding into LLMs. With OpenAI, we have what's called a ZDR. So when OpenAI, we send our tokens to OpenAI, they just do inference and then they delete right away and they don't train on that data. So if our customers are okay with that, then they're fine. We also have customers who are even more security focused. Where we're actually building out right now, like stuff where we can like host the data on their premises and actually run open source models on their compute. It's not too much lift because like Teo has like done a lot of work to like build out our agent infrastructure in a way where it's just plug and play and you can replace like OpenAI with like an on-prem provider. So in the limit, we're able to do that too, but for now, most of our customers are okay with these standard kind of security contracts. That makes sense? Yes.
But-
So you're building this knowledge graph
Yes.
for different clients. Is this different universes? Like let's say two
Yeah,
clients
different
have.
universes. Different universes, because we can have data contamination, that's like a big violation.
Okay.
If Ram's customer data leaks into Stripe, it's like, we're like that. So we have.
Yeah.
Strict separation. The only thing that's shared is public data. So when we are doing news scrapes and stuff, we do reuse that kind of work, obviously. Other than that, complete strict separation, and that's enforced at like a architectural level. Yeah. Sure.
But we do have like a base level of shared public data. Like if we go on to Google, if I go to Google or read Wikipedia and it's there, like that's public, right? So that's totally okay.
And like, we
Yeah.
are scraping and extracting and persisting that data into structured data sources. So like, we are doing this pre-compute work, which we then can reuse.
Yeah.
But,
I don't know if we are scraping. We are third-party vendors scraping.
well,
right?
well,
Yeah.
I mean, yes, but obviously we have like, providers, but like we're building like a layer which then scrapes and then processes, makes it structured and feeds it into an
Yeah.
Yes.
So what's the minimum, the thing connecting the agents and this knowledge graph? Because LLMs need a like simple JSON prompt.
He will talk extensively about that.
Yeah. Yeah. So thanks for the graph overview. Let's see. So yeah, I mean, a lot of times, the joke is like, oh, someone's building an LLM wrapper, right? GPT wrapper as a startup or whatever. But it's mostly a data problem to scale at an enterprise level because I also saw this meme where it was like, oh, NVIDIA is a TSMC wrapper, and TSMC is like a silicon wrapper, and silicon is like a sand wrapper. You can go down to the earthly levels. But like at the end of the day, yeah. Right. Yeah. But at the end of the day, it's all about like anyone can build, send requests to, these OpenAI responses API or whatever it may be. Very simple, which is why it's so great, right? You see a lot of builders building stuff. But the whole point for us is like actually making this scalable to like at an enterprise, level, right? We can't, we have to be deterministic as much as possible. We have to show something that's verifiable, reliable, and users can put confidence into it. So that's why we have so much focus on our data layers, because of all that, so that we can reliably present that data into a useful manner. So now, how does the agent come into this picture? The agent. So right now, what we have is we can build an amazing SaaS tool, right? A software as a service tool. So we can have amazing UI that has a React dashboard, I don't know, Next.js, whatever. And it's already there. You can click around and you can do all your research, see the research results, maybe schedule emails, things like that, on your bills, email stuff, outreach. But now the whole point is the next step is everyone's so used to ChatGPT, right? What they do is they copy and paste our content and they bring it over to ChatGPT and then they ask questions on there, right? But that's now a whole different layer of kind of scary of unproductiveness right there, right? So what we do is we've hooked up our agent in a manner where it can directly interface with our graph. And we've done several iterations over it. So one way that we had was we built basic interfaces so that our whole graph, which lives on Snowflake, can be directly queried by the agent. So the agent, basically, if you think about it, technically the agent is very good at writing SQL queries, right? Like I'm sure you use, ChatGPT to generate code or whatever. So we were like, oh, let's try throwing in like the most basic building blocks to access data, which is, just a bunch of SQL queries. Hopefully it can do joins and whatnot. And that was a big failure because our graph was one, way too big for the agent to actually process, and two, too many tasks happening at the same time, right? It has to figure out like, oh, like the high level details of like what does a salesperson care about the product, and also figure out how to actually write the SQL and make it so that it works with our schema, right? So there's like so many problems that are each very complex that we've grouped into a single agent. So that was like but that was an experiment that we had to do. Because theoretically, if this worked out, we don't ever need to build any data tools at all, right? We just need to maintain a single data tool that, oh, the agent now is smart enough to query, our internal schema. But no, it did not work out, unfortunately. So what we had to do was we had to step back and create abstractions that were one layer above what our endpoints provide, because our endpoints are, pretty raw in the sense that it's meant for other engineers to, client engineers to consume it so that they can render it on a screen, right? So we know exactly the data points that they need. You could even use tools like protobuf and whatnot to, make it even more efficient so that, theoretically, you don't even need, labels on your data because, index 0 might always have, the name, and index 1 might always have, the email, so on and so forth. But our LLMs love language, right? So there's this in between, the the rawest forms of data and, a very high level description where we have a JSON schema that describes the data, but also we provide other little tidbits of information. So for example, one thing that I think Gopal was working on was providing citations. So because users do not trust LLMs fully, and including myself, right? I always need to check if Perplexity or ChatGPT is hallucinating or not. We need to provide the users with the source. Like providing the data is not enough because if I need to track down where the data came from, and like I'm already wasting time on that, right? So making sure that the LLM cites something in a reliable manner has been proven to be really challenging because, when LLMs, when they do inference, injecting like random citation tokens, like, oh, there's citation 0 or, whatever it may be, is not really something that's inherent, I guess, to its behaviors. And, to overcome things like that, whenever we access data, we also provide a little citation token so that the LLM is reminded of exactly where the data is coming from. And also, hopefully, it looks at the citation token and realizes that, hey, I need to put that in to the user output as well, so that we can also present it to the users. So things like that, seems like a very little things, but it's something that we've learned as we build something at you know enterprise scale, so that we can actually present it to users so they can actually use it directly in their meetings or whatever data form that they're creating out of our agents.
Just kind of add
Yeah,
on to
sure.
that. It's like this idea that the agent put the general concept is that when you're like the idea is that when the agent takes actions or reads stuff or writes stuff, we can actually like inject instructions or tokens like when like based on certain events that happen at runtime, which is like a really powerful idea. Like when you read an email, like it's a simple thing, but again, like you mentioned, when you read an email, we like inject citation tokens into that read, and then we prompt the LLM like, if you got citation tokens, please make sure to like include them. And like instead of like the naive thing is just like prompt the LLM, oh please cite the data, like blah blah. It never works. Well, like this kind of thing was based on at runtime. It's essentially a runtime prompt injection is an idea we also use by and stuff like that is like very important for like getting things to work at enterprise scale. So basically what you're saying.
Yep. We also have things like tools to fetch more tools. For example, it's pretty interesting because as soon as you put something in the prompt, whether it's uh, instructions or whatnot, the agent is going to be biased towards that because it does a bunch of in-context learning, right? But one thing you could do, whether it's to save time inference time, as well as to save, tokens if, money is an issue. Well, money is always an issue. But yeah, the context length is you can create tools so that it can try to fetch more prompts, right? For example, say that you want to provide an ability to, generate a sequence of emails. But that's a lot of instructions because, to generate a sequence of emails, you need to figure out what you're going to talk about in the email template, and who you're going to send it to, as well as the frequency. There's a lot of things I can't even like list it off the top of my head right now. But you could theoretically just have a tool, right? Just like, for example, in our terminal, you might have used man before, right? For the manual tool. Like you can just type man caffeinate and you can learn about how caffeinate works. But similar to that, you can basically build man for your agent so that it can actually internally query your docs so that it learns what to do on the spot without having to, conflate its context window with all the irrelevant features. Well, irrelevant for that conversation, because we have a lot of features, but most of the times our salespeople, they are focused on a single task at a time, and they will not be using any of the features until they are ready to use those features, or they're in a new conversation. Because like when you're doing research about a client who's like at very beginning stages, most likely you're not going to be creating slide decks, or for I don't know, or yeah, or like sending a contract, right? Like the contract is at the very end of that step, right? So we don't want to keep our agents distracted all the time. So, things like building tools to load more tools, or more instructions. Because at the end of the day, it's, abstractions are very pretty, and we love building very pretty abstractions because we all come from an engineering background. But also, what's nice and not nice about LLMs are that everything at the end of the day is the inputs are strings and outputs are strings, right? And trying to, sometimes, you can bend the rules so that, you just randomly inject a string, and, and if it works, the hard part is actually parsing that string out of the LLM so that it's, structured. Yeah.
I just had a quick question, like, could you kind of explain, like, so is it like a lot better for the LM in terms of how it performs when it has a single like tool that accesses more tools versus just having all of those like secondary layer tools at its disposal from like the first layer? Does that
Yeah.
make sense?
Yeah. So I think the whole point for us is to not overload the LLM's context with too much stuff at the same time, right? Because but say that there's like a step where there's like a multi-layered step. So say that you want to create a slideshow, right? And you want to create an agent that can actually create a PowerPoint or something. But if you think about PowerPoint, there's a bunch of tools within PowerPoint, right? Add image, move text, create text, add new slides. But we don't want our main agent to have all those tools ready. Well, I mean, theoretically, if our agents were, if the LLM models were much smarter than what we had right now and had like much larger context windows, sure, like let's throw in the whole computer, right? And some companies are trying to do that, right, with the computer use models. But right now, it's pretty much, I think, unusable because it's way too slow and way too expensive. Uh, so say that someone's trying to create a presentation. Unless they're doing that exact action, they're never going to need the PowerPoint's tools, right? So what we do is we don't load those tools or present to the agent that it has those capabilities until it is ready to do so by saying, hey, I want to create a PowerPoint now. Give me all the abilities. And then we'll type in, new set of prompt, replace the system prompt, or, provide by transferring to another agent, things like that, and providing those secondary layer tools. Because yeah, those tools on itself are not really useful, right? Yeah. But yeah, that's a very good question. Yeah.
It's all, as you mentioned, like spring in, spring out. I don't know if you have, what's the transition between the knowledge graph and the agentic workflow? Is it like, can you convert your knowledge graph into some kind of embedding that kind?
I mean, very, very simple, like what you said, that you can create like these descriptions of the data, like would we have like 20 or 30 like common queries of the knowledge graph, like nine all my meetings, like in a certain time range, or like stuff like that. But those are queries that now, because we can ingest all the data, we can just write this query. So we basically wrap these queries in these data tools and give the LLM really nice descriptive JSON schemas of what it's seeing. And in our
Okay, sounds good.
forms right now, in our experience right now, it forms pretty well. Doing that. So that's a good question.
Yeah, but a lot of the queries, I mean, so theoretically, if we had like a free-form SQL, you could do any types of queries where you could join like this column with that column that has nothing to do with each other. But a lot of times, like we try to build within like a salesperson's workflow. So theoretically, we could do something like that if we just, query the database raw. But we try to make our tools so that they are like reasonable abstractions of like what a person would think, so that relevant data are grouped together so that they when someone asks about my deals, maybe it will load everything about that deal as well as one layer beyond, so all the person and all the people that are involved in that deal and their maybe LinkedIn information, because we've commonly seen that as soon as someone's talking about the deal, the salesperson would like to also know about like who should I reach out to. So it's a fine line between like should we just generate like data clients and have the machine, just query out everything. And from our perspective, because we know what the users are trying to do to a certain extent, we try to build it in a manner where it's grouped in a logical way so that it's not just, technical, but how a salesperson would act on those data. But yeah, that's a very good question. So it's like a mix of, it's mostly JSON, but we can also inject random sentences because it is at the end of the day a strings to help guide the.
But when you act data, we also inject custom instructions, custom computer instructions on the fly. And we have all these tricks at runtime where we basically inject things at runtime based on context, deterministic, non-deterministic. We use the benefits a lot to like improve performance.
Yeah.
So
And yeah, I know we're running out of time, so I'm slowly going to wrap up the conversation. But if you are either interested in, building such systems at scale, whether it's our data platform, there's also, the data engineering aspect / data science, where we try to filter out the most useful piece of data, because we have a lot of data that's constantly being streamed into our system, and we got to figure out what's relevant and what's not, which is also relevant to our track forward, which is our challenge, is, just, find a bunch of real world data and try to make some good use out of it, because real world data, very dirty, it's not like your clean CSV that's used for a PSET or whatever, right? Might bring up bad memories. But yeah, unfortunately, they are not very clean, and that's what we deal with. Or whether it's the agentic systems. So if you're interested in, the latest research on how do we make these systems actually more smarter, useful, because a lot of the questions we don't really know, right? It's all experimental, right? Like, like whenever a new model comes out, we test its limits. Is the context window good enough? Is it actually maintaining its attention level, so on and so forth. So yeah, if any of these questions, problems, and also we have the scale, right? We have global enterprises using us. So we've grown beyond the GPT wrapper person, let's say, so that, we can actually battle test these LLMs so that, it works reliably, quote unquote. But yeah, if any of those problems interest you, you should definitely talk to us. We're at the booth at the ice rink. But yeah, we also have our challenge prize.
it's a challenge.
Yeah, the challenge is, get a bunch of dirty data, real world data, and try to make good use out of it. Whether it's, clean the data and then you do some action. For example, with us, we, get people data and we'll try to figure out who's the most relevant person to talk to. Whatever data you find, if you make it useful.
But actually do something with it.
Yeah.
Like, we don't want you to just like give us a report of like, oh, here's the thing that we want you to do something.
Yeah.
Operate in a messy environment and do something with it. Like, or have a system that takes action.
And yeah, we have a crazy price on it too. So yeah. Yeah, but yeah, feel free to hang around. We can Gopal, Nanya, I are also going to be here, and we also have Marco and Damon at our booth right now. So yeah, make sure to talk to them. But yeah, thanks for coming. Have a nice day. Bye.